The development of a forest view monitoring system has been in progress since October of 1995. At present, we are working on applications using two forest video recording robot cameras installed in the Tokyo University Forest in Chichibu. The first is the Natural Forest Crown robot camera, which captures the details of the branches and leaves of a tree. The second is the Forest Scene robot camera, which films entire forests, either natural or artificial. First, let's take a look at the Natural Forest Crown robot camera. Since 1991, comprehensive research has been underway at the University Forest in Chichibu. To elucidate the ecosystem of a mountain forest, a research area has been set up in a forest of primeval beech and Japanese beech 1,200 meters above sea level. A 25-meter iron monitoring tower erected in the research area is used to study tree phenology, insect populations, and the cryptoclimate for vertical layers of the forest from the ground to the crown. At the top of the tower, a field video camera has been set up with computer-controlled direction adjustment and zoom functions. The crowns of beech, Japanese beech, and Calopenex pictus and others are recorded in many different zoom magnifications. Every day, the camera is automatically pointed in 40 preset directions for recording. As the camera is set up in a forest with no available electric supply, a gasoline generator is used that starts with a timer made out of a combination of a battery and a solar cell. Next, let's take a look at a Forest Scene robot camera. Basically, this camera is the same as the Forest Crown robot camera. The only difference is the camera section itself, which is designed for indoors. Filming from a distance of 600 to 1,000 meters, the camera records the seasonal and yearly changes of natural forests of Japanese beech and hemlock spruce and various others, or artificial forests of Japanese cedar, cypress, larch, and other species. To augment the data from the recordings of the landscape, a weather observation tower is set up in the forests to be filmed. The wind direction, wind power, insulation, temperature, and humidity are measured, recorded, and regularly collected. In this forest, computer graphics have been used since 1991 to research and develop a photorealistic technique for simulating real forest landscapes. We are applying a plant growth model to the modeling of a tree shape in collaboration with the AMAP unit of Chirad in France. The plant growth model can generate computer simulations of more than 200 plant species according to the age of the tree and season. The shapes of the simulated plants are based on detailed data on three-dimensional shapes extracted from enormous amounts of measurement data and botanical knowledge. It can be represented in the form of a line tree, polygon, and real rendering. For application to forest landscape, the forest growth model was developed. If you're carrying your notebook PC, forest data is accessible anytime. The forest data associated with the forest is recorded in both the forest stand inventory and forest type map. This data has been input to GIS, a geographical information system. If you input your location using GIS, the system will return information on the types and ages of the surrounding trees. A three-dimensional perspective of a forest can be created from the forest information and topographic data. In addition, by planting AMAP-generated trees in a computer, you can complete a highly realistic forest landscape simulation. The computer-simulated forest can be dramatically modified by changing the season or by cutting down or planting trees. This forest landscape simulation serves as an effective visualization technique to help understand various research underway in a cyberforest. The video and meteorological data recorded with the robot cameras is used as the basic data for simulation. In this way, the video footage recorded with the Natural Forest Crown robot camera and the Forest Scene robot camera have been digitalized and linked with meteorological data online, thus providing highly detailed forest data which is intuitive and easy to understand.